Hi everyone, and welcome to our first Germination Strategy Session webinar of 2017. Today we'll be looking at blackleg mitigation in canola. My name is Mark Zinkowitz. I'm the editor of Germination and germination.ca, and today I'll be serving as your moderator. First, I'd like to thank our sponsors, 2020 Seed Labs, Canterra Seeds, and CCAN for their support. I'd also like to note a few housekeeping items. This webinar is being recorded and will be made available on germination.ca following the event. For audio quality purposes, all microphones have been muted with the exception of speakers. If you have a question or comment, please share them in the chat box on the bottom left side of your screen and let us know who they are directed to. We certainly welcome your input. Also, viewers are welcome to keep tabs on Twitter as we'll be sending out live tweets during the webinar. Today we have two speakers to talk about blackleg mitigation in canola, Justine Cornelsen and Peng. Both will speak for around 15 minutes, and Justine will be our first speaker. Agronomy specialist, Canola Council of Canada for Western Manitoba, Justine graduated in May of 2014 from Brandon University with a Bachelor of Science degree in biology. In the past, she's worked as a summer student with the Canola Council and at AAFC Brandon in the barley breeding program. She utilizes science and innovation to promulgate the current best management and sustainability practices to growers and industry partners. Justine will talk about mitigating blackleg from an agronomy perspective. So let's get started. Over to you, Justine.
There we are. Thank you very much, Mark, for that introduction, and hello to everyone online viewing today. So today I am going to be focusing on blackleg and mitigation of it from an agronomist/grower perspective, and I'm going to highlight quite a few items that Gary's going to kind of fill in the blanks with the research that we have going on here in Canada. But just first to start things off, I want to just go through the blackleg disease life cycle. This is an area that we really need to communicate with growers and our extension people, and making sure that everyone has a full view and understands how this disease works within our field. So to start off, blackleg is a canola fungal disease. It restricts nutrients and moisture movement, which then cause premature death or ripening in the plant that contribute to then, at the end of the season, yield loss. So the main species of blackleg that we deal with here in Canada is Leptosphaeria maculans. So this is an early season pathogen that it likes to infect the plants as early as the cotyledon stage. With infection at this early in the season, it allows for the pathogen to then move through the plant and cause cankering at the base. So this is where that constriction happens at the stem and root, and where we start to see that drying down of these plants. Leptosphaeria biglobosa is then the mild or weaker virulent species of blackleg here in Canada, and it's often usually associated with upper stem lesions. This, however, is a species that comes in late season, and it doesn't cause a whole lot of yield loss just with our really short growing season here in Canada. But this species, however, biglobosa, is the one that the Chinese deal with, so they currently don't have Leptosphaeria maculans. So that's where our trade concerns come in. But looking at our disease life cycle here, majority of our canola is infected at that early cotyledon to 6-leaf stage. This is from the Leptosphaeria maculans fungus overwintering on infected canola residue. So the spores produced from the diseased stubble are the major source of the pathogen that contribute to widespread field infection, resulting in yield loss. So in the spring, the fungus produces these fruiting bodies called pseudocychia. From there, they then produce ascospores, and so these are the small sexual reproductive spores that continue the infection within a new crop. So they become airborne, and they can travel long distances throughout the wind, and this is how we start that new infection into the crop. So they initiate the disease, and they allow for that spread of new races of the pathogen within our field. So, like I said, dispersed by wind, rain, and that's kind of the ideal conditions that the blackleg pathogens need. They really like that wet environment to get going and start to releasing their spores out into the atmosphere. A second way of getting infection in your field is through pycnidia. So once plants are infected, they will start to create these these whitey kind of clear spots, and they'll develop these tiny little fruiting bodies called pycnidia. So from there, they're like tiny pepper-like spores. From there, then they release more pycnidiospores and continue on that infection, causing a secondary infection within the crop. But so our main way of infection is through crop stubble. So when a new canola field is brought in, it's the stubble that is introducing that infection back. I've left in this disease life cycle the infected pod portion and seeds. With new work here in Canada, we're finding that this really is not a problem here in Canada. We don't see infection through seeds and infected pods just because we have such a virulent early form of the disease. So that comes in at that cotyledon stage. At that point in time, then through our cleaning processes, this is not an issue anymore. So new life cycles will be axing this component out, the infected pods and seeds. Very rare to see those symptoms here in Canada. I like to stress the scouting throughout the entire season. So with blackleg, obviously this is an extremely important issue to growers. Majority of growers are also getting their agronomists to scout for this. So before we can deal with this disease and within the field, we need to deploy management practices. So we need to know what we're dealing with first. So learning how to identify blackleg, it comes in all shapes and forms. So like I said, we've got the pycnidiospores, so the tiny pepper-like items on leaf material. When we cut open roots, we're going to see that blackening and that constricting of the root and stem all the way into the pseudodigia, so the large fruiting bodies on stubble. The problem we have with blackleg and identifying it gets mixed up with a lot of other of our canola diseases. So let it be sclerotinia or root rots. We have this misdiagnosis, and these diseases need to be handled differently and at different times. And they do have a variety of different management techniques. So coming back into the field, it is just knowing what you're actually dealing with, and then you can move forward from there to create management practices to actually mitigate your problem. Just want to highlight a field. This is just a field from last year. We saw in 2016 these really large, huge biomass crops. And we also had extreme weather events, bringing all sorts of storms, hail, and rain, lots and lots of rain. So we saw a lot of crops lodging and falling over, and this actual field here had these spots that were lodged, and that actually ended up being blackleg. So going to those spots, pulling up plants, cutting them at the base of the plant, you were able to then identify the blackening. So this crop was actually falling down because of the disease. So that's another point of confusion. This disease looks a lot like a lot of other symptoms. So it is ground truthing what you're dealing with and going and actually pulling up plants. So just to highlight what's going on here in Canada with our disease and why blackleg is becoming coming back to the front and on the concern of our growers and our industry, we're seeing the prevalence of the disease start to climb back up. So we, in the late 90s, introduced a resistance gene. So we then started to see this plummet. So you can see in the 2000 range, we dropped down to really low levels of the disease actually being found in our fields. And now we're starting to see this upward trend. So this year, Manitoba, we were seeing around 82 of our fields that were surveyed through provincial surveys showing blackleg within them. Alberta was over that 90 mark, and Saskatchewan around 62. So that is a huge portion of our fields actually showing the disease within them. When we look then to actual incidence, so this is the number of plants infected by the disease or from all fields surveyed, we actually kind of dropped down and are at lower numbers, but we're seeing still a climb from years past. So from about 2009, we're starting to see this, once again, upward trend of the disease within our fields. So more and more of the plants are becoming infected with blackleg. Our canola disease surveys across the prairies are done differently, but here, majority of them are done on this 0 to 5 rating scale. So we go into the fields, we pull up plants, we pull up roughly 100 plants to give this rating for our fields. So we do look at how many plants are the incidence, and then the severity. So our severity number is based on a 0 to 5 scale. So 0 being plants showing no infection through the cross section. and 5 being a very severely infected plant, most likely dead and completely blackened within the stem/root. So that's how we base our rating for blackleg, and this is something that's easily done for growers wanting to have a better handle on how much yield they're potentially losing and how they're going to change their management practices. This is something to go and do right before harvest, right before you go in there with the slaughter combine, and to determine actually, you know, how bad was this disease within your field. With that information, we can then move forward, and we've got our severity. So across Western Canada, this is actually kind of positive. We're seeing our severity of the disease stay pretty well the same. Manitoba, well, actually all prairie provinces, we average around that 1.5, so very, very low severity rating, which is positive to see, and this is probably because of our use of resistant genetic genes deployed in our varieties and cultivars. But from this number, we can then determine the actual yield impact. So taking severity, we can, with new work that was done out of Alberta last year, we can now identify how much loss growers are seeing from blackleg. So taking that 0 to 5 scale of infected plants and looking at the seed yield per plant, and then a wide range of varieties. So we've got Westar on here being a susceptible canola variety. We've got 54 S53 being a resistant variety, and then a moderately resistant variety being 1950. So with that, we can see this linear relationship. So the worse the disease gets, obviously the more yield we're losing. So we take our average of 1.5 as a severity for Western Canada. We'll be losing upwards to 30% on that plant. So from every point you move, so from moving from a rating of 1 along to 2, you can estimate to be losing anywhere from 17 to about 24% yield loss. So when we look at that at 1.5, that does put us around a 30 mark. So when we look at the 2016 growing season, Western Canada had an average crop yield of 52 bushels an acre for canola. Our severity rating was actually at 1.4, so slightly less than what I was saying. And we plop it into this yield loss monitor, and Canadian canola growers were seeing upwards of 5% yield loss because of blackleg alone. And when you start to run the numbers and look at how many production tons were lost because of the disease, and then look at that commercial value, that's upwards of $400 million lost because of this disease here in Canada. And that's, once again, at an extremely low severity rate, but it's here, it's in majority of our fields, and now we're needing to look at mitigating this problem and bringing it back to lower levels like we've seen in the past. So why such a push for mitigating blackleg risk? Like I just mentioned, you know, it is robbing some of our producers of yield and equating to huge dollar amounts. So not only is this a huge issue for our Canadian canola growers, it's also a huge issue on the international trade front. So many of you followed last year our story with China. So one of our major canola markets, they were looking at lowering the standard of dockage, so that material that's taken over with seed, they were wanting to lower it down to a standard of 1% of the foreign material from a current of 2.5, because they are concerned of the risk of spreading the Leptosphaeria maculans pathogen into their production areas in China. So our research found that the reducing the risk from 2.5 down to 1% of foreign material doesn't really equate out to any sort of, it doesn't mitigate your risk anymore. So luckily our Canadian government did come to an agreement with the Chinese, and they did settle back on the 2.5 dockage standards until the year 2020. So in this period of time, this next 4-year period, we need to look at mitigating it and lowering it back in our field. So what can canola growers do to help manage this disease? And that is bringing those levels down. So we want to see that incidence level come back down to about 10 years ago. If we can get it under that 20%, if not 10% level, just to show our canola markets all around the world that we are doing everything to manage and mitigate this problem. So the forefront of of managing this disease is looking at the risk and what sort of risk growers are willing to take. So this graph, majority of you have probably seen this before. It's fairly standard. There is one slight change in it, which is around our gene rotation and quantitative resistance, which I'll come to that at the end once I go through each of these levels. But these activities are things that growers need to be asking themselves or thinking about when managing blackleg, and they cannot rely on one of these alone. They have to incorporate all of them. Management of all of our diseases needs to be looked at a full picture, right? We can't focus in on the small little details. We need to encompass all these practices. So starting off, scouting number one, I'd already highlighted that at the beginning. Scouting is so important. If you don't know what you're dealing with, how can you deploy any other sort of management techniques? So growers that are actively looking for the disease, then they can apply some of these other management practices to help lower or mitigate their problems. One of these ways is the evidence of the disease, so the pseudothecia, so the fruiting bodies on old stubble. This you can do in the fall, you can do in the spring right before you're putting in a canola field. Find some old stubble. If you're able to find the fruiting bodies on there, that's a pretty good indicator that you're going to have the disease within your field again. Crop rotation. Rotation of crops, rotation of products, rotation of cultivars. This is all extremely important. With blackleg, it is a brassica disease. So with our Canadian system, really, it's only affecting our canola crops or those occasional mustard crops. So if we can extend that rotation out, we're not giving the disease in our field that susceptible host anymore. So the general recommendation is 4 years. That's just that the spores will hopefully die off on old stubble by that time. So that puts you at the low risk. Unfortunately, we do have large areas in Western Canada that don't have many cropping options, so they do have canola every second year, which does put them at a very high risk for that disease. I'm going to skip over our gene rotation and quantitative for right now. Canola volunteers and weed control needs to kind of fall hand in hand. So any of our brassica weeds, so like I said, mustard, and our volunteer crops in the off years, right, they're still a susceptible host, and they're still a way for that disease to continue out its life cycle and supply more of the disease and pathogen back into the field. So if we can manage those, that'll help mitigate it in those off years that we don't have canola. Our seed source, once again, this is a point that we shouldn't have to worry about too much because we all are purchasing certified treated seed. The risk is when if you are using bin run, you're using a second generation of your seed, so it may not have that resistance package for blackleg anymore, causing concerns. So then your fungicide application. Fungicides are a preventative measure, so you have to go in before you see the disease infecting that crop. So you have to ask yourself these other questions in your scouting. Were you seeing pseudothecia? Am I on a tighter rotation? Are the environmental conditions perfect for the disease to take off and spread their spores? So this is a decision you have to make before seeing it within it. Because it's preventative, if the plant is already infected with the disease, it's too late, right? We've got to coat those younger plants prior to the actual infection. So the recommendation is 2 to 6 leaf, if not even early. So that cotyledon stage to 6. If you're targeting your window at 6 leaves, the majority of your plants are probably already infected. So that fungicide application is only going to prevent further infection and spread of the disease. So that's just something to consider. Now back to the two. These have kind of been brought forth in the industry, our gene rotation and quantitative resistance. So in the past, the general recommendation was to just switch varieties. That's all the information we were given, right, was to just switch to a different variety and hope that you were picking a different resistance package. So now, moving forward, we hopefully will be supplying the industry with more information on the genetics and how growers can then successfully rotate between different cultivars using different resistance packages. Our quantitative resistance, this is our cultivars, just our resistance label for right now. So the current label that we've been using, so a resistant variety, a moderately resistant variety, and then susceptible. So once again, you don't see very many susceptible, you see no susceptible varieties on the market. It's pretty well just resistant or moderately resistant. So this, in combination with your R gene, is going to help growers in the long run make a decision on their cultivar choice. Once again, if they're dealing with an actual problem with blackleg, and like I said, you can't rely on these two alone. So just to kind of bring everyone up to speed. The canola industry last week voted in favor of incorporating R gene labels with our current blackleg field rating. So that is our R, our MR, S, and S ratings. So those are based on a percentage of a check of Westar. So these labels would be combined now and associated with each cultivar commercially available. So it is a voluntary process for seed companies to participate in. So this means that companies can choose to identify and label major genes used within their cultivars to allow growers the option to selectively choose a different resistance gene to manage blackleg in their fields. So this option will benefit growers that are having a problem managing the disease, where in the past that general recommendation was just to switch varieties and hoping that they pick a different resistance gene. Growers will now have that information, so they're no longer guessing. They'll be able to make an informed decision and pick a different resistance gene. So Gary is going to explain the science behind this a little more, but the short form is that when you use the same resistance gene over and over again in a tighter rotation, the pathogen within your field is going to start to turn virulent, so that aggressive form, and it's going to attack and then infect the canola plant. At this stage, then our minor genes or adult plant resistance then starts to kick in, and that helps to slow the rate of infection of blackleg. But at this point in time, we're still working on measuring adult plant resistance in our cultivars. It's not something easily done, so we are working towards a protocol and better ways of measuring this. But as for identifying resistance genes, this is just another step in the right direction to provide growers with a little more detail on what varieties they should be choosing, and only if they are having a problem with this disease. So this is not a silver bullet to mitigating blackleg here in Canada, right? This is just more information and another management practice that needs to be incorporated with all of our other best management practices outlined for blackleg. Just to highlight some benefits of incorporating an R gene system, it is going to help preserve our advanced genetics that we already have in place. So it takes pressure off the industry and researchers to keep creating new cultivars with new novel sources of resistance. So France and Australia have both been using similar R gene models to manage blackleg in their canola growing regions. These models are deployed slightly different and tailored obviously to their growing needs and concerns. But here in Canada, we are just hoping that it provides growers with a little more information on what variety they need to be switching to. It's going to help promote our environmental sustainability by minimizing that fungicide application. So this ties back into the whole rotational piece, right? If we can rotate crops, if we can rotate cultivars, if we can rotate products, we're going to help keep our agricultural practice here sustainable in Western Canada. So this will be a key component moving forward in a bunch of our environmental farm plans. And then also it's utilizing the deployment of the known means to prevent changes in that virulence and pathogenicity with Leptosphaeria maculan field population. So Gary is going to speak a little more on this and what is our current research finding and how our pathogen is quite diverse and what ways we can then help manage and tailor to those specific crop needs. So that is just kind of an overview of an R gene rotation system. The Blackleg steering group will be working with the seed industries. We already have an R gene group model in place. So right now it's roughly 10 different groups that canola growers could then rotate their varieties through potentially. Like I said, if you are on an extended rotation, if you're scouting, if you're using your fungicide application, you can continue to grow the same R gene variety over and over again, right? This is only if and when you have a problem that you need to be thinking about this a little more. So like I said, it's a whole package deal. This is just an image from Australia, actually, at one of their blackleg disease nurseries. So this is what happens when you continue to use the same R gene over and over again in Australia. Obviously, they have a very extended growing season and a very severe virulent form of the disease, so it's able to overcome resistance very quickly there. So this is what we want to try to avoid, and luckily we have 8 months of winter here in Canada, so the pathogen doesn't shift as quickly as we're seeing it down there. But they are able to predict when this is going to happen, when they are going to see this breakdown, which will then allow growers to pick a different variety for that growing region. So just a quick run through on our blackleg management, right? I can't stress that enough, is learning to identify the problem you're dealing with. Even a really good looking canola crop may have blackleg in it, right? So it's getting out and scouting, understanding when that disease is going to take off and flourish. So this last year was prime example. We had warm, wet conditions early spring that allowed for that pathogen to produce more spores and infect through this year's crop. Crop rotation, and not just crop rotation alone, like I said, rotation of everything, our cultivars, our genetics, our products, our fungicide applications. We need to keep rotating this. Rotation is so important, and diversity is so important. So bringing in those other crops to help extend our rotation is going to prove dividends in a lot of our management techniques and skills. Resistant varieties tied really closely, obviously, to our resistance stewardship. So, right, we can't take advantage of the resistance genes we have out there. The industry has brought forth a really great set of genetics, and we want to help preserve those for the long run. So we don't want to wear them out in any way. We want to be able to continue to grow canola here in Canada and use these varieties and genetics that are already in place. Certified seed, like I mentioned before, extremely important in mitigation, and then that early season fungicide application. So getting that correct timing is very crucial, and I think that's where majority of growers aren't very happy with their early season fungicide. It's because they put it on too late and are missing that key window. So just last, before I close off here, stay informed. We've got lots of new things to come this year moving forward in the industry. We are going forward, and producers will be able to view the RGene groups. Not all seed companies will be on board this year. It is a voluntary process, so have that discussion with your seed rep and see if they are willing to do this. Hopefully we'll see a few groups, or a few seed companies this year using the new RGene groups. But if not, we'll start to see more next year, just because this is it just happened last week that we agreed on a model for here in Canada. So with that, I will conclude, I guess, the first portion of this webinar today. Thank you all for your time. My contact info is there if you want to have a more in-depth conversation about blackleg. I just scraped the surface of many things going on within the industry and with the disease, and Gary's going to fill in a lot of those research gaps and where we're going forward and why we're making these decisions on moving forward with mitigating blackleg here in Canada and canola.
Thank you very much, Justine. If you have questions for Justine, please type them into the chat box now. We will now commence with the Q&A part of our webinar. The first question I have, Justine, is how far do the ascospores disperse from their source of infection?
So this research is older research, but the rough recommendation here in Canada is about 1 kilometer. So the recommendation from if you had a very severe canola crop, you want to then push your crop even further if you're growing canola the next year, even further away. So roughly 1 kilometer. Once again, it moves in the water, in the wind, but that is just the general recommendation. In Australia, I believe they're 500 meters. So if they grew canola last year, they don't want to grow another canola crop within that 500 meter radius. So it does vary, but that's kind of the rough range of how far these ascospores will disperse.
Second question I have is, how long would it take pseudothecia maturity to begin ascospore release the following season?
So we are starting to see a lot more of this. I'm not going to speculate exactly on what the exact time frame is. But when we have canola on canola, we will see Pseudothecia that following year. Ideally, it's 2 years after when you start to see the Pseudothecia really ramping up, but it's not impossible to see it that year after. So that's why these tighter rotations, the Pseudothecia really flourish on the dispersal of their ascospores.
Question number 3 is, and I'm thinking this may be related to the issue of R gene labeling. How will producers know which gene groups to use?
So this, the R gene model that Canada has agreed to use will be publicized here within a few weeks, so everyone will see the groups. For right now, it is just a group A, B, C, D sort of format. From then on, then it'll come back to your seed company. So when you buy your canola seed, typically you see that R rating. The new grouping will be attached onto it. So it'll be R-A as an example. So you've got a resistance cultivar in the field that is using group A genetics. Let the example be RLM1, so that gene. Moving into a different gene, cultivar, you're using a resistance gene, so R dash B, so encompassing, LEPR3. So that's just a rough example of what that label will look like. The Blackleg steering group will be creating a management guide for the industry. So this will be a yearly publication that outlines the risk and then ways for growers to manage their risk and incorporate that a cultivar list, hopefully, that will outline how you rotate between these genes, because some genes react to the same pathogen with their field. So there is some very concise wording that has to be applied to some of these groups and some of these R genes.
Question number 4 is, if there's more than one major gene in a variety, which resistance group would it be?
So this is kind of the nice thing with our Canadian model. We'll then pair the genes together. So you'll take group A and B and combine them together, because some of our cultivars are using several major genes. So back to my example, so we've got the R-rated cultivar, and it could be using RLM1, RLM3, and be combined, so then it would have a label of R-AB. As a rough example. So then that, going forward, would mean that grower in 3 or 4 years, if he was to grow canola again, would want to avoid a cultivar that falls into group A or B. So they would have to move to something completely different. So you will see varieties with several groups attached to them as well. So that's why this management guide that'll come out will outline all these specifics and give examples. And there does have to be some really concise messaging given around how a system like this works.
I want to thank Justine for making time in her busy schedule to share her insight and expertise with us today. She is going to stay on the line, so if you do think of a question you would like to ask her, you will have an opportunity to do so before the end of the webinar today. I hope that everyone has found her presentation valuable. Our second and final speaker today is Gary Peng, a research scientist, Saskatoon Research Centre, Agriculture and Agri-Food Canada. Gary's areas of expertise include blackleg and clubroot diseases in canola, plant pathology and integrated disease management, host-pathogen interactions, and mechanisms of host resistance. His current projects include monitoring and analysis of Leptosphaeria maculans race dynamics in Western Canada for effective blackleg resistance management, and also mitigating blackleg disease of canola using fungicide strategies. Gary's going to talk about his latest research and what it reveals about blackleg mitigation in canola. Over to you, Gary.
Thank you, Mark. Hello, everyone. Justine has explained the overall management strategies in the following, probably from the research perspective, to provide us some research data or information which will provide a rationale to what the recommendation Justine has just mentioned. Okay, we'll go from here. Okay. I'll just give you a few more slides to look at the symptoms of blackleg. Often when you drive by at a later stage, the symptom is the premature ripening. That's pretty evident in patches. And when you look a bit closely, that's where that concentrated the premature patch is like. When you open the canopy, and then you will see the diseases develop mostly at the base or crown of the plant, and some with lesions, some without. But often it is the canker type of the symptoms. When Justine was mentioning about the lodging, that's how can it happen. And in this case, when at the base the tissue becomes weakened, and it can fall down during the wing. Okay, and in other cases, you may see extended lesions on the stem. It seems to be developing from up and down, and that's often related to early hail damage. The blackleg pathogen really like wounds. When they have wounding on the plant, they don't need a high moisture condition to infect, so that's where the post the hail damage, the infection can happen. Justine highlighted some of the trend of the disease development over the years. As many of us recall, and before in the 90s and the early 2000s, the disease was relatively well controlled, mainly because of two factors. One is the resistance of variety, and also the rotation, often 3 or 4 year rotation use. And it's about 2009, 2010 we start seeing the creeping up of the disease, especially the incidence. And Justine has explained quite a bit of those. I'll not get too much into this. But what I wanted to explain is what are potentially the reasons for what's happening or the increase of the disease level we're seeing. And the first is the pathogen, the population adapting to the varieties we have or resistant varieties, and also the cultivar that used to be resistant are no longer effective against the current pathogen population because of the pathogen change. And you probably heard a lot of the seed companies highlighting the non-specific resistance, durable resistance in their varieties, and we also look at those that aspect and to see how effective that resistance is, and finally look at the fungicide through our the research. So I will provide the information and explanation in those aspects in the following slides. First, we look at the pathogen population. When a resistant variety needs to act, it requires the pathogen population to have a corresponding avirulin gene. This is what we call the avirulin gene in a higher frequency, and that's where the interaction will be a resistant one. I will explain a little bit more of that relationship later in one of the later slides. But when we look at the current pathogen population characteristic in terms of AV gene or the avirulin gene, we can see that some are high, some are low in terms of frequency. In this case, in 2014, the AV3 or AV1 were quite low already, and why others are relatively higher, and that's one thing. And secondly, from region to region, in this case, province to province, there are some variations. And for example, for the AVG 6, and in Manitoba was much lower than the other two provinces. Why are these? What's the importance of this information? When we're looking at the use of the resistant gene, this is the base we use to select the R gene, and we need to know the pathogen, the race profile, to determine what the effective resistant gene can be. For example, in this case, when we have AB2, 4, 6, 7 are at a high frequency, correspondingly, the resistant gene RM2, 4, 6, and 7 can be highly effective. So that's the reason we put a lot of efforts in doing this type of work. Another thing is that the pathogen population changes constantly, but in the short term, they may not change as much. But when we look back, what was in 2007, there can be substantial changes, especially when we look at the AB3, they're still at about 50% in 2007, but it was almost down to zero in 2014. So that was the change that can happen over the longer term. Well, just to have a quick explanation of how things work, we have so far about 16, 17 major resistant genes. For each of those genes to be effective, you need to have a high frequency of the corresponding AV gene in the pathogen population. And this example, if we have a variety carry RM3 gene, so we have the AV3 infected the plants, then we have a very little development of the infection here. And if it's virulent 3, and then this infection will develop really rapidly and through the PDO into the stem and cause major infection. So that's how this resistant gene and the AV gene interacting in this form. So we looked at the pathogen AV gene profile, and then we said, well, what is the resistant gene situation in our variety? And ideally, we would like to have the R gene matching the high frequency AV genes. But in this case, my colleague and I looked at about 200 varieties or breeding lines from Canadian company, and the most predominant one are the RM3 in those lines or germplasm. And RM1 was also noticeable, but in reality, I'll show you another set of data. In the cultivars, probably RM1 is more common than what was showed in the last slide. These are 8 commercial varieties we tested from different seed companies, and most of them will carry both RM1 and RM3. Okay, so you may ask, we have those 2 R genes in the variety, and then the corresponding AV gene were both low in most of the areas. Why are we not seeing the widespread disease damage on the prairies yet? So that comes down to another the factor of the resistance is the quantitative resistance. The good news is it seems that for most of our varieties, there is a good background of resistance there, and although it is quantitative, sometimes it can be affected by other factors like environment. So what we did in the research is to estimating how effective this non-specific or quantitative resistance can be. What we did was to use the 3 representative commercial varieties and then inoculate them with the pathogen not carry the corresponding AV gene, like AV1 or AV3. So in this case, what we found was that we, as Justine mentioned, the early infection is very important. We inoculate the cotyledon and then look at the development of the infection through the PDO into the stem. In this case, this is on the Westar. There's no resistance at all, and the disease develops quickly into the stem. But for these commercial varieties, and we look at the ultimate disease severity index and also the mortality, and those can be significantly reduced on our commercial varieties, despite the fact that there is no corresponding R gene against the AV gene of the pathogen. Well, we further evaluate that with the ddPCR protocol, which measured the amount of pathogen DNA in the tissue in both the PDO and the stem of the inoculated cotyledon. And there is a clear difference in the amount of a pathogen development into the PDO and the stem. And that's probably affected by the speed of pathogen spray and from the inoculated part of the cotyledon into the stem. So that seems to show the mechanism of this non-specific resistance, how it react or act, and as a differentiation from the major gene resistance. Another evidence of that is to look at the development of the pathogen hyphae from the infection site. These are 2 locations, and further into the PDO and the stem. This is the susceptible cultivar Westar and versus the resistant variety, and you can see the speed of the development was much slower on the resistant variety here. So that's how the mechanism is for the non-specific resistance to work against the infection of the Blackleg. It is a very important function for us. So we have been relying mostly on this function in the recent years. That's probably why we're still seeing the severe damage as more of isolated cases instead of a widespread. Okay. I will skip this slide, and other than just saying, from the development of the mortality and of this commercial cultivars, they are much slower in comparison to the Westar showing here. That's the days after inoculation. Okay. The last point is the fungicide treatment. It can be used as a potential risk mitigation measure. When we were starting this project, we asked 2 questions. One is what the product would be effective, and what the spray timing would be effective. So we choose the Westar as a kind of a worst case scenario for resistance breakdown, and look at the early application at the 2 to 4 leaf stage, and versus the bolding stage, or even with the 2 applications. And for the product, we have 2 kind of a strobilurin type of product. This tilt is the old triazole fungicide. The quilt is a combination of both active ingredients. When we look at the 17 station years altogether, and looking at the disease incidence, disease severity versus the yield, and we seem to see that the Streptoline type of product, headline and potters, would reduce all those disease levels significantly, and also can increase the yield of canola. The later application would not be as effective using headline, and the two applications didn't seem to improve the efficiency that much, and the yield either. So that's the overall picture. But when we look at the data further and separate the disease levels from the light to moderate to severe, if you recall the figure Justine presented, where that the disease starts impacting the yield, and that's around the 1 to 1.5 of severity. And in this case, all those 9 station years would have a disease level below 1, or severity level below 1, and none of those treatments was effective. But when in other 8 station years, and when the disease level, the average on the non-treated control was around 2.5, and similar the treatment, the early application, and it was effective. So basically, the first slide that showed that the efficacy of fungicide treatment was mainly because of these the more severe disease situation where the early application of a fungicide will work. If it's that was the worst case scenario for most of the fields with either R or MR kind of a variety, and those the early treatment, even the early treatment, despite of the fact that it reduced the disease level to some extent, and the yield benefit was not significant. So basically, for the fungicide treatment, the first thing you look at is your risk factor there. If you have been scouting your fields and knowing the amount of a disease in your field and the level of your variety, of the resistance in your variety, and a lot of the time you can kind of look at the fungicide the treatment as probably well, at least need to have the moderate level of risk to be able to justify the use of that $18 in your field per acre basis. Another possibility we're looking at here is the seed treatments. Current seed treatment with the fungicide is more of a targeting the root rot type of early pre-germination disease. But in Australia, the seed treatment itself is not effective enough. But in our case, because of the shorter season and a relatively less level of disease pressure, now might be a more cost-effective fungicide treatment than the foliar application. In terms of the yield benefit, that's probably another area we should be looking at, and we are investigating it. Well, just to sum up for the research perspective, and we certainly recognize that the increase of the blackleg in the recent years, and also the prevalence of AV genes in the pathogen population that would provide a base for us to select the effective R genes against the current pathogen population. Now, research certainly emphasized both the major gene resistance and quantitative resistance are important, and this effort of identifying the more robust quantitative resistance should be continued, and some of our current protocols might be used for screening of those quantitative resistance materials. The early fungicide spray can provide the value only when the disease level is moderately high, or disease pressure is moderately high, and the seed treatment might be more cost effective in Western Canada. So that's probably the research report I have. So if we have time, I can entertain a few questions.
Thank you very much, Gary. If you have questions for Gary, please type them into the chat box on the bottom left of your screen. The first question I have, Gary, is can cultivars with multiple major genes of resistance provide the same durability as rotating genes year over year?
Well, theoretically, it may, but we also need to recognize that this particular pathogen can evolve quite rapidly against the resistant genes. So it's just a matter of time. The pathogen will break them. So in a way, we may be better off to look at the rotation of different genes on a specific site. The Australian colleagues, they look at the multiple genes. They found that they were also broken, but they call those strains super strain. So we probably really needed to avoid that if possible. At the beginning, certainly it may have longer durability than the single gene, but eventually we think that, the pathogen will be able to break all of them.
Second question I have is, are you aware of any recycling of non-effective major resistance genes in Australia or Europe?
Well, it happens with, sometimes it's the nature of the pathogen AV gene interaction. The case in point is probably the RLM3 and RLM7. It seems that the RLM7 has been more lasting in Europe to this point, and often when the AV7 gene starts going down in the pathogen population, and the AV3 seems to be become more prominent, and that will allow the resistant gene RLM3 to be reused in this case. At least that's the hypothesis at this time, and we probably still don't have a lot of the actual data, especially from the field, to really confirm it with more R genes. But it is a possibility. It's more of those things that were based on the pathogen population monitoring. So as I emphasized, that's the strategy going hand in hand with the rotation of a resistant gene. You need to know what the AV genes are in the pathogen population.
And third question I have, Gary, is can you recap how is crop rotation related to blackleg severity?
Well, the key issue here is that, do you have a virulent population of the pathogen? And if you do, what is the inoculum amount that will generate a high rate of infection? So it is a numbers game. If you can rotate your canola or out of the canola for give it more than 2 years break, there is a good chance that the residues will decompose more completely in the field. In that case, the pathogen would not be alive in the residue and would have a much less amount of inoculum to be produced. So theoretically, even though you have a virulent population there, you have a much smaller population to deal with, and then you have less chance to have a severe infection, and also less chance of a mutation or further changes in the pathogen population. So in a way, the longer crop rotation will certainly have a multiple benefits in terms of disease management.
I'd like to thank Gary for taking the time to share his insight and expertise with us today. I hope that everyone has found this information valuable. That's all we have time for today. Again, I'd like to pass on my thanks to our sponsors, 2020 Seed Labs, Secan, and Cantera Seeds for their support. I'd also like to quickly thank Kyle Dradawani and Teresa Kurdziewicz, our team working behind the scenes, for their dedication to making this a successful and informative event. This presentation will be made available online at germination.ca within 24 hours. Thank you very much for your attention today, and on behalf of the team here at Germination, we hope you all have a great rest of your day.